All right, day 5, question 1. The graph shows the distance a certain motorbike can travel at a constant speed with respect to time. Which of the following best describes the meaning of the slope of the line represented in this situation? Well, slope is rise over run. All right, so that's going to be the change in y over the change in x. And so we want to look where the x is about 1. So right here's 1, but that would be off the chart. But I can see over here, it's got to be at least above 8 or 9. So since the slope has to be above 8 or 9, I can eliminate, really, a slope of 6, 2.5, or 5. All of those are going to be too small. Okay, so since I can't tell on the 1, I'm going to look at the 1/2. So at 1/2 here, I go to 5. So that rise is 5 over that run of 1/2, or 5/10. So when I divide 5 by 5/10, I'm going to get 10, which is what Jay says. The motorbike travels at a speed of about 10 miles per hour. All right, question 2. A can of baked beans has a diameter of 6.6 and a height of 9.9 centimeters. Find the amount of baked beans that could fit in the can, round to the nearest tenths place. All right, they do not come right out and say it, but they're wanting us to find the volume. So I need to use my reference material, find volume, find cylinder. So my formula is volumes equal to capital B times H. And this formula works for cylinders or prisms, so I have to figure out what my base is. And for this can, it's going to be a circle. So I'm going to replace big B with the formula for the area of a circle, because capital B stands for area of a circle. So I got to come find area, circle, pi r squared. So I'm going to replace that B with pi r squared. Okay, that's how I find the area of that circle base. And then I multiply it by the height. So I'm just going to use 3.14 for pi. Oh, I can't plug in a diameter for radius. I'm going to have to half this to 3.3. So I need to use the radius, 3.3. It gets squared times the height of 9.9. Put all of that in your calculator at one time. Squared button is over on the left-hand side. And I'm going to get 338 and about 5/10. So over here on my answer choices, the closest thing is right here. And that answered my question. All right, number 3, Angela recorded the price of different weights of several bulk grains. She made a scatter plot of the data. Use a trend line to extrapolate the price of 50 ounces. So this fancy word here, extrapolate, is just going to mean that we're going to have to use information that's not on this grid, this graph. It's outside the graph. So we want to know for 50 ounces. So we have a couple different ways we could do this. We could find the slope, or we could kind of use some common sense. So right here, I want to know how much it's going to cost for 50 ounces. I have 18 ounces. So this is counting by twos, 14, 16, 18, 20. So at about 20 ounces, it's $1.80. So if we just think about this, if 20 ounces is going to cost me $1.80, and I need to get to 50 ounces, well, I could double that 20 ounces, and half of 20 ounces is 10 ounces, and half of $1.80 is 90 cents. When I add that up, $1.80 plus $1.80 plus 90, I get $4.50 for 50 ounces. So just using a little bit of common sense, I can figure out that the weight of 50 ounces is going to cost approximately that 4.5. That's the closest thing I have there. All right, or you could find the slope, which is the rise over the run. So you would need to find a good point on this trend line. So we've got 0, 0, so that's good. And then I need to find another point. So at 2, it looks like it's about 20 cents. So the rise would be 20, and the run would be 2, and that would simplify to be about 10 cents. So I could say that y is equal to 10 cents x. Just replace the x with the 50. All right, and when you multiply 1/10 times 50, you're going to get about 5. And again, the closest thing here would be that 4.29. All right, question 4. The drill on an oil derrick descends, goes down at a steady rate. The depth the drill reaches over time is shown by the graph. Based on the graph, which is true? All right, all of these answers says that it descends. So can't eliminate anything that way. But I do know, because I read a graph from left to right, that this graph is sloping down. So this is going to be a negative slope. So I'm dealing with a negative slope. So I can eliminate those positive slopes. So B has a positive slope of 12 and C has a positive slope of 6. So it's either going to be A, negative 12, or B, negative 6. Well, again, if I could figure out what 1 is, so for 1 hour, it's about right here. Right here is negative 12. So I'm counting by 4s. So this would be negative 4, that would be negative 8. And at 1, I'm somewhere in between negative 4 and negative 8. Well, that's not going to be 12. That's going to be negative 6. In between 4 and 8 is 6. So that would be, it's going to descend at a rate of negative 6 feet per hour.